everyone. This is Vivek, working as assistant professor in Department of Computer Science and Engineering, and I'll be going to deal about OOPs through Java subject. So, in order to understand the Java, first we have to learn what object-oriented programming is. Okay, OOPs stands for Object-Oriented Programming. Procedural programming like C, etc., which we have previously studied, they deal upon the procedures and methods that perform operations on the data. While object-oriented programming is about creating objects that contains both data and methods. Data and methods. Okay. So object-oriented programming has several advantages over procedural programming. It is faster and easy to execute, provides a clear structure for the programs, and OOPs make it possible to create full reusable applications with less code and shorter development time. So this is one of the greatest advantages of object-oriented paradigm over procedure-oriented. In procedure-oriented, we used to have to write code for every time we use, but in object-oriented programming, once we write the code, we can reuse at n number of times, anytime we needed to. We no need to again write the code. We can reuse it as many times as we can as further we go into the programming. Okay. So this is the picturization of the object-oriented programming. It contains the basic things called classes, which in turn contain data and member functions, and they are interrelated to each other. All the objects are interrelated to each other. This is the paradigm of object-oriented programming. So the key features of object-oriented programming, which makes it the best for the today's world, are the features are objects, classes, abstraction, encapsulation, inheritance, and polymorphism. Sometimes we also call them as buzzwords, Java buzzwords when we use in Java. So let us see features one by one. The first one is an object. Object, anything can be an object. Any real world entity is an object. An object is a basic unit of object-oriented programming that represents real-life entities, based on which we will be writing the program. In the procedure-oriented thing, we use it to write a procedure and embed all the actors in that. Whereas in the object-oriented programming, everything is taken object as the base and we write the program around it. So the objects are what you perform your code. They are part of your code and visible to the viewer and user. So we'll be writing everything centered upon the object. An object mainly consists of state, behavior, identity, and method. State means with the state in which the object is. It is represented by the attributes of the object. Next, behavior. It is represented by the methods of the object. It represents what they are going to carry out. What is their specific function in the given code. Next, we have the identity. A unique name is given to every object so that redundancy might not occur. Next, we have a method. A method is a collection of statements that perform some specific task and return the result to the user. That specific task, we sometimes call them as functions or methods. Both are one and the same. They are used to execute a specific task and give the results. We will be dealing more into these methods and functions in the coming classes. Next, the class. This is one of the main pillars of the object-oriented programming. It is a user-defined blueprint or prototype from which objects are created. It represents the set of properties or methods that are common to all objects of one type. So all the similar kinds of objects they are grouped into something called a class. Using classes, you can create multiple objects with the same behavior instead of writing their code multiple times. As we have said earlier, the main advantage of object-oriented programming over procedure-oriented paradigm is that we no need to write the code multiple times. We can always reuse the code. Using classes, you can create multiple objects. Okay. Now, in general, class declarations can include these three components in the given order. One are the modifiers. This is one of the important concepts. They give the access modifiers, we call them as. Those are public, private, and protected. And of course, a default, which is also have the properties of public. So we will be going into more detail about access specifiers in the coming class. What are they and what are their properties, etc. Next, we have a class name. The name should begin with the initial letter capitalized by convention. It is not a mandatory, but it is a healthy practice to give the class name as first letter capitalized. Next, we have the body. The body of the class is surrounded by the braces. We declare the variables, data types, operators, and functions, whatever we require in the class within those two flower brackets. This is regarding the classes. Next, the important concept is the abstraction. So an abstraction is the process of hiding the implementation details and only showing the essential details for the features to the user. So here we are going to hide the implementation and we are just going to show the things that gives us the results. This is one of the important concepts because the users are concerned with the results, end products, but not how we are going to achieve them. For example, if you take a switchboard as an example, you go and switch on a particular switch, either to switch on the light or switch on the fan. How that is working in the background is immaterial to us. Okay, all we see is just a switch that resembles a specific function. One switch to switch on the light, another switch to switch on the fan, etc. Okay, so we are going to use only those switches. As far as us, the users, are concerned, that is the only thing that matters. What we are going to see, which is going to perform the function. So background is hidden from us, which is unnecessary to us. So this is one of the important concepts of object-oriented programming. That is our abstraction. So it allows us to focus on what object does rather than how it does. So here we are going to show what it is going to do, but not how it is going to do. Next, the unnecessary details are not displayed to the user, which are practically immaterial for the user. We are not going to show him. We are just going to hide them. That is only for the developer to worry with. Next, another thing. That is encapsulation, and the name itself suggests it's is going to represent a capsule. Inside the capsule, we will be having a different kinds of things that are used to perform the same function. Okay, so encapsulation is defined as a process of wrapping the data and methods into a single unit. Typically, we use a class for that purpose. Okay, so we are going to wrap them in a single class. In the mechanism is a mechanism that binds together the code and data. It is going to bind together the code and data. Another way to think of encapsulation is that it is a protective shield that prevents the data from being accessed by the code outside the world. When we want to keep the things, the objects or the methods within the class itself, not to share with the outside world, we practically use the encapsulation purpose. Technically, in encapsulation, the variables or the data in a class is hidden from any other class and can be accessed only through any member function of the class in which they are declared. They can be accessed only by the member functions which are declared in the class, which are not available for the outside classes. Encapsulation can be achieved by declaring all the variables in the class as private and writing public methods in the class to set and get the variables. So these are one of the access modifiers, public and private. So before going into the details, I will just inform you one thing. Public, when we declare something as public, it can be used by all other classes which are even outside the package also. But when we declare some classes private, that means it is available only to the classes that are declared within the same package. So that is the main thing which we have to understand. And this encapsulation is achieved by declaring all the variables in the class as private. Variables means the actors, the agent, the objects which are present in the class. They are private only to the class. And then we will declare public methods which shows the execution to the others by achieving the abstraction as well as encapsulation. So next, one of the most important thing we can consider this as a pillar of object-oriented programming is the inheritance. As the name itself suggests, inheritance is something which passed from the older generation to the younger generation. Here also, all the objects and properties and methods of one class, we call that as a parent class, are transferred to the child class or a subclass. Okay, in this mechanism in Java, by which one class is allowed to inherit the features, fields and methods of another class. We are achieving inheritance by using a extends keyword. So by declaring something as extends, we are going to use the class. Inheritance is also known as a relationship. If you see the picture here, we have the animal class. Let us say animal class is our class, animal is our superclass. Animal. Okay. So we will be writing some content in that. Then if we want another, let us say the dog class. So we are going to do something like this. Class dog extends animal. Okay. And by using this, what happens? All the properties that we define under the animal class, they are automatically inherited to the dog class. So this is called inheritance, which is one of the important features of object-oriented programming because it supports the code reusability. What is code reusability? Once we write the code, we need not to write again. That is code reusability. So once we write a code for the animal class, we obviously know dog is an animal which is having some unique properties of its own. But again, it is basically an animal. So when we inherit the methods and fields from the animal class, we here mention only things that are exclusive for dog. Okay, all the things that comes under the animal class are directly inherited from the animal class. Let us say dog only barks. No other animal can do that. Dog barks. So bark is a method that is particularly coming to the dog. Okay, remaining all breathing, eating, etc., all comes under the animal class, which are directly inherited to the dog class. So when we mention the dog class, we need not to mention the all other things that an animal class automatically does. So here we will be mentioning only things that a dog going to do. Let us say some barks or method, something like that. Okay, so this is inheritance, which supports code reusability to a greater extent, and it helps in having the hierarchical use of data, which we'll be seeing in the coming classes. Next most important feature that object-oriented paradigm is going to give us is polymorphism. At the name itself suggests, poly means many. Okay, the word polymorphism means having many forms, and it comes with the Greek word poly, which is many, and morph is the forms. This means one entity can take many forms. Polymorphism allows the same method or object to behave differently based on the context, especially on the project's actual runtime class. Okay, so this polymorphism is mainly classified into two types. We call that as compile time and runtime polymorphism. So compile time polymorphism gives us method overloading, and runtime polymorphism gives us method overriding. These are two important concepts which we'll be dealing further. For the time being, just understand that method overloading deals with same class with different parameters declared in that, and here method overriding means same method having same parameters. Okay, so we'll be dealing in detail with them in the coming classes. So that's it for the day. So these are the important OOPS concepts that are going to be used in the Java programming language. So we will meet with the history of Java and basic entities of Java in the next class. Thank you.